I'm Piotr Wikowski, the IoT evangelist at Transition Technologies PSC. And today with me, I have Tom Bogat, the PowerShift product owner, and David Robinson, head of technology and innovation at Capula. Today, we'll be talking how PowerShift is helping EDF change the energy market in UK. So hand it over to you, Tom.
Thanks, Piotr. I'm Tom Bocut, and I'm the product owner for our virtual power plant or flexibility platform called PowerShift. So for those of you who don't know EDF, EDF UK, we're the largest supplier of energy to businesses in the UK. We have 8 nuclear power stations, around 30 wind farms, and gas and coal generation in the UK. Overall, we provide around 20% of the UK demand. And right now, like a lot of the industry, we're very much focused on the transition to low carbon and supporting the fight against climate change. So EDF UK sits in part of a global group, and that global group has a target to double the 2015 level of renewable energy, so developing new wind farms, solar generation, up to around 50 gigawatts globally by 2030. Alongside that, we will be adding 10 gigawatts of energy storage, so putting batteries onto the network around Europe and globally by 2035. So that's 5 gigawatts on top of what's already operated by EDF Group. And our other ambition is in the electric vehicle space, where we hope to be the leading energy company across Europe. So before we look at the PowerShift technology, I'm just going to give a little bit of an introduction to some of the concepts of power markets that drive the need for flexibility. So one of the key physical aspects of a power market that make it very interesting to working is the need to continuously match generation with consumption. So in real time, the grid has to balance generation and demand. And in the UK, our grid operates at 50 hertz. So any fluctuation in the balance between generation and demand will see that frequency move away from the target of 50 hertz. And if it goes too far away from that target, the system will become unstable, and it leads to blackouts. So national grids have the responsibility of ensuring the system is constantly balanced. So that drives a lot of structure of the market and a lot of what we do in the industry. So one of the things that's becoming more of a challenge as renewable generation becomes more and more a part of that system is that the natural fluctuations that you see in generation mean that job of balancing becomes more difficult. So you have things like intermittent generation, like wind, where it can very quickly change. Also, you have a move from large centralized generators like a coal station out to distributed generation, which is much smaller. It's much more spread around the country. It's on solar panels on top of buildings, small generation all around the country. So a lot more different pools of generation to manage. So as a result, there's more volatility in the market. So we're seeing at the moment, for example, we're seeing a lot of negative prices in the market. So because of the reduced demand due to people being in lockdown and businesses being closed due to the COVID pandemic, and high levels of solar generation during the summer, we're actually seeing unprecedented levels of negative prices in the market. So that means, for example, that you can get paid to charge a battery. So it's kind of analogous to going to the petrol station and actually getting paid to fill up your car. So for us, that can be an opportunity. And there's also many different revenue streams that you can access if you have flexibility in your generation, so you can turn it on and off quickly, or flexibility in your demand, so you can provide services to the national grid that you get paid for helping to balance the system. And we see that the need for those services growing as the system transitions to low carbon. And we're also seeing a future of increased connectivity. So of course, IoT, industrial IoT, more and more devices already connected and controllable through the internet means more and more flexibility on the system. And another factor is, as we bring more electric vehicles, we see an increase in consumption, but it also introduces a lot of storage into the market and more flexible assets. So the industry is seeing a future where there's more and more need for flexibility on the system and more opportunities for people with flexibility to access different revenue streams. So our aim in developing PowerShift is to build this connection between the trading floor that you can see on the right. So this is the EDF UK shift trading desk, which operates 24 hours a day, 365 days a year, continuously optimizing our assets for our portfolio, buying the energy for our customer demand. And we're looking to connect to sites such as this one on the right, which is a large solar farm, and down the bottom here you can see the 5 containers, which are 5 storage units. So this is around 6 megawatts of storage capacity, and there's around 10 megawatts of solar at that site. So our interest really is connecting assets that are flexible to energy markets. So PowerShift is the technology that we've created to help do that. So PowerShift is around, it's a platform that enables flexibility, optimization of assets, so looking at how to run them in different energy markets, and the trading activity that goes around that. Really, in simple terms, we're looking to enable assets that can be either turned on, so turning on a generator, or turning off some consumption, turning down the fridges at a warehouse, or increasing or decreasing the level of generation or demand. And that flexibility is supported by data analytics and controls technology, as well as live market data feeds, and all that comes together to kind of give a fully linked system for optimizing and trading as many flexible assets as we can connect. So PowerShift has several building blocks. So we have a customer portal, an online portal. We have an integration API gateway that joins all the components together. We have an optimization and forecasting engine that connects to the trade floor, and we have some settlement capability where we run the calculations each month that understand the cash flows in these fairly complicated contracts that we have with customers. But the area that's of interest today is our asset management system, which we've developed in ThingWorx, and that is the core of the platform. It has our operator's user interface. It has all of our API frameworks, and it links. It provides connectivity, obviously, down to any physical controls equipment that we put onto sites. So our story with PowerShift started back in around April 2017, where we had a vision of the key building blocks that we would need to build this flexibility platform. And we knew that right at the heart of that would be connection and control. So we were exploring several different options and avenues for that capability. We were looking at AWS, for example. We had looked at OSI Pi, but around the middle of 2017, EDF acquired Capula. So Capula became part of EDF Group, and Capula's background is perfect for us because their background is control and monitoring for the nuclear industry, and they're a systems integrator, so they were aware of a lot of the different products in the space that we were looking for something. So Capula had already started to look at ThingWorx as something that they wanted to move towards. And they saw a lot of value in. So they introduced us to ThingWorx, and we very quickly got ourselves comfortable with it. We were signed up for the demos. We were using the development portal and understanding the application, and we saw it as something that looked really good. So in winter 2017, we actually did our first proof of concept with Capula, and at this point we were working in the car park. We had a very small diesel generator that you can see there, the little orange box, and some slightly larger controls hardware. And we had all of that connected up to ThingWorx, and we were able to turn that generator on and off, monitor the generator, read the frequency from the generator, all through the ThingWorx API framework. And then as the PowerShift project moved forwards, we were really interested in moving into the battery market. So we had been doing a lot of bespoke development in AWS, but we kind of saw the potential for ThingWorx as an accelerator because of the kind of rapid application development capability, all the security frameworks, the fact that it's hosted meant that we felt we could very quickly develop a solution to get us into the battery optimization market. So in a very short space of time, over about 6 to 8 weeks, we went from a standing start with ThingWorx to having a full solution in place for optimizing our first battery, which was at one of our training facilities called Cannington Courts. And that project was successful, and we kind of saw that ThingWorx could become a broader capability for us in the whole PowerShift architecture. So we kind of expanded the role of ThingWorx. We kind of took a big pivot in the project to use it as our core data engine, as well as our interface for all of our operators who run the flexibility platform. And in that process, we did realize that we needed some really strong PTC expertise, and that's where Capula helped us by bringing in Piotr and the transition technologies team. So we saw the capability of ThingWorx, but we wanted some people who really knew how to get the best out of it. So since that kind of initial pilot in the car park back in 2017, we've now grown to the point that we have 300 megawatts of assets being run through the PowerShift platform. So to give that some context, that's equivalent to supply for about 20,000 homes. So it's been a good journey, fairly long journey, but we've been able to grow really well with the help of ThingWorx. So there are a couple of case study projects that we have. So as I was mentioning before, the first battery that we ever connected to PowerShift is at Cannington Court, which is a listed building in Exeter, which is in the west of the UK, and it's a training facility that a lot of the teams that work at EDF, particularly the teams that work on the nuclear power stations, come for their training. And we have a lot of pilot projects at that facility. So the EDF built the battery at Cannington Court, and a lot of the people who visit there for training will see the battery. We've also had an interesting project with Nissan. So Nissan factory in the north of the UK in Sunderland. there's a project that they're exploring, building batteries from electric car batteries. So the idea is as the battery gets older and it's not suitable for the car anymore, you collect those up and you build a larger battery that you can optimize and use for providing revenue from energy markets. And then around April last year, we brought on kind of our first more significant in terms of scale project, where we had a 6 megawatt battery that we saw earlier, co-located with 10 megawatts of solar, and we had a very nice product for Enesco in terms of underwriting some of the revenue for them that has become quite popular in the market. And we've also been able to work with them with 2 other sites, which is around 40 megawatts of battery capacity. And then looking forwards, EDF is, as I was saying before, already has in the UK a 49 megawatt battery that we don't use in PowerShift at the moment, but it's developing more grid scale batteries. So over this year, we're starting to introduce really quite large batteries up to 50 megawatt batteries, which is kind of over 30,000 homes worth of power that you're talking about there. And this is what PowerShift looks like today. It didn't look like this in the first tactical solution. It's been improved, and we've been able to improve it and iterate it over time. But what we're looking at here is live monitoring from the Cannington battery. So we have visibility of the grid frequency, so measurements coming in every second of the grid frequency. We can also see the current actual power output of the battery, and we keep track of that on a second by second basis. We also see these blue boxes are the schedules of the battery. So in this example, you can see the pattern of charging the battery and discharging it. So we're constantly buying and selling power with the battery during the day, and tracking the live state of charge and feeding all of that into the decision making in the trading floor and in those optimization tools that the traders use. So the live connectivity of the asset is really key to us. Piotr, thank you. I think you're going to talk a little bit now on a bit deeper into the actual technology and architecture.
Yes, thanks, Tom. So I really liked your building blocks slide, but now I will just talk through this in a little bit more details. So PowerShift consists of different components, systems, and tools. So on the left, in the top, we have control partners, which take the live metering data from assets and make sure that they work according to schedule. On the right-hand side, we have some forecasting system providing us with forecast data. In the center at the top, we have AMS, our asset management system, which is based on Single application and serves as a central data storage and API gateway. Down below, we have abstraction layer, which is connected directly to grid, but also is our integration platform. We also have some optimization tools, and everything is based on the AWS cloud. The connections you can see here are APIs or endpoints. We decided to use REST because it's very simple, yet very powerful, and it's built on a secure HTTP protocol. So REST is using JSON to transfer the information. JSON format is human readable, but also systems and applications can read it with a very good performance. Here we can see one of our test assets. And yes, this is like creating a virtual representation. So no matter what type of an asset the customer have, we can create its digital representation and store it in PowerShift, in ThinkWorks. This is like creating a digital twin. So we have a physical device, we created virtual representation and connects this too. As data flows, we can observe our physical assets sitting in the office many kilometers away. This is the base for predictive maintenance and analytics. And now let's switch over to the components of the PowerShift, which allows PowerShift to participate in the National Grid's balancing mechanism. So let's start off with forecasting. The majority of assets for majority of assets in PowerShift, the output is determined by running at the optimized schedule. For renewables like wind, solar, this is determined by weather conditions. So having weather forecasts, our RGFS, or Renewable Generation Forecasting System, reads that weather forecast, saves it, also have some historic power information of an asset. Then the BUMI, our implementation platform, reads that forecast, transforms that to the AMS format, and then it is being persisted in AMS, from where it can be used to calculate physical notification. And physical notification is what National Grid is using in its balancing mechanism. So let's see how the balancing mechanism of National Grid works. Now, National Grid is using the physical notification format. Physical notification is the expected activity of a balancing mechanism unit. It is used by National Grid to balance the supply and demand. When it's needed, National Grid can instruct the balancing mechanism unit to change its planned activity in order to retain the energy balance in the grid. In this case, balancing mechanism unit is the minimal unit that can be used in demand-side response. It is usually a group of assets. So we enable the asset grouping in PowerShift, creating virtual power plants. So asset grouping allows us to see the group as a one unit. It also enables data aggregation, physical notification, of course, but also we can aggregate some live metering data and energy schedules. Everything is used to balance the energy in the national grid. So very similar to the asset, the PMU has its virtual representation. We created characteristics like national grid ID, name, and so on, but also define APIs like get physical notification, add or remove assets, and everything is built on top of a ThingWorx abstraction called NetWorks. The very important bit of our PowerShift system is also the ability to remotely control assets. And this is what Capilla offered, and these are the Capilla control boxes. In fact, they are small computers running Linux, so we can create a remote desktop connection to that control box. And then, because the control box is connected directly to the asset, we can check the status, send instructions, turn it off and on, or just perform the maintenance of the asset. Here on the photograph, we can see the actual Capilla control box as we use in PowerShift today. Now, of course, the system is nothing without the application. And the releases introduce the production downtimes, which then might introduce additional cost to the ADF. And this is why here on PowerShift, we worked really hard in order to reduce the time to market and reduce the production downtime. So effectively, we can, at the moment, due to help of the automatic pipelines, we can deliver new features every week because first, using the automatic processes, we eliminate the human errors. which might be a case with manual processes, but also it allowed us to reduce the production downtime to a little bit more than 4 hours to just 30 minutes. So at the moment, we can just click with a single click of a button, we can enable our automatic pipeline and release new features to production system. All right, so this was a let's say a very like a scratch on the surface of how the PowerShift is how the PowerShift looks like and how it's working. And now let's hand it over to David, who will be talking about how the cooperation of 3 companies made it all happen.
Okay, thanks, Piotr. My name is David Robinson. I'm head of innovation and technology at Capula, and I was involved at the very beginning of the project, as Tom described earlier in the presentation. And it's been a very exciting time to be involved in such a new service that's coming to the energy market. And it's been really good to work as a team member with 3 distinctive groups that have worked on this project. And throughout the project, the importance of team collaboration cannot be stressed enough, because we've got teams that are in different, geolocations, highly distributed, working remotely as well. And it's been an integral part of the project to bring all of these people together, and it has delivered enormous benefits through that collaboration. EDF themselves have provided really smart leadership, with project managers defining roles and distributing tasks. Our collaborative teams have held regular meetings and stand-ups, so they shared a clear vision of the direction we were heading in. Every team member involved knew the full scope of the project and what they were accountable for. This allowed each team member to perform efficiently and save time, money, and effort as a direct result. In addition, we had a diversity of knowledge within the team. EDF with their energy markets knowledge and their idea of the vision of the solution that they required to meet their needs. Capula with our systems integration and automation control background. And Transition Technologies with their in-depth ThingWorx software development experience. All of these combined knowledges were brought to the project and have helped us immensely over the course of the project. Another element of the team was its openness. Our team was one where teammates were open and honest with each other throughout. Everyone on the team was welcome to ask questions, offer ideas. This openness created a trustworthy environment where everyone was encouraged to share their ideas and experiences, discuss important aspects of the product, and communicate with others on the team. Of course, we had disagreements along the way, different ideas about taking different paths on the project, but it was all in good nature and definitely helped with the end delivery. Now, a positive attitude within the team is an undeniable sign of effective collaboration and successful software development and project management. A happy team is a more productive team, and the PowerShift team definitely kept high levels of positivity throughout the project. We had lots of small, informal discussions at the beginning of the meetings just to check out what the team was doing, how things were going in general. We had a number of events where we celebrated accomplishment of specific tasks and sending thank you messages around the team or to individual team members in general chat, and providing meaningful feedback without criticism. These are all very important, and maintaining that positive attitude as we continue to develop along the project. To help us, we used great collaboration tools such as Jira and Confluence to support the team. Collaboration software is fully used for discussion ideas, distributing tasks, monitoring project progress, communicating with clients and teammates, and keeping everyone in sync. So without doubt, the combination of the team collaboration of EDF, of Capula, of TT, accelerated product development, and allowed us to get the product to market faster, since the team addressed difficulties together. Team collaboration drove creative thinking and effective brainstorming. It allowed us to look at problems from multiple angles and points of view. Developing a successful solution utilizing PTT's ThingWorx platform will also need a good team behind it. And on this project, we definitely had one. Thank you for watching our presentation. We hope that you found it informative and potentially useful. Please feel free to reach out to any of us, plus provide your feedback. It is very much appreciated. Thank you.